Okay, cool. Thanks for joining outside on Friday. Let me make sure. Oh my god. Can't do that. There. Let me pull up YouTube and just show what I did was after we all were kind of like brainstorming and wrote down stuff on those note cards, I just tried to summarize what we were talking about with about 20 minutes. I gotta cover myself up. So this last video from Friday recording, that was like summarizing all the work that we've done on Friday. And I didn't capture every single note card because it would have taken a while to like go through everything, but I tried to like generally summarize like what were some things that people were thinking and different approaches and that kind of stuff. So that'll be what we'll build quiz number 1 with, so that we can, and all the quizzes are take home similar to that first quiz 0, where you have some time. It should take about 20 minutes. Like if you set aside 20 minutes to do it and submit it, should be enough time. So it's not like a really long. There's something. Are we supposed to be protesting something? I mean, in general, yeah, there's a lot of problems that need some help. I don't know what that is. Does anyone know what's going on? You're all engineers. You have no idea. Not to say that engineers are always disconnected, but the stereotype is that your head's like either in front of a screen or a book or something. I was there. I'm still there because I don't know what's going on. Like a what? Oh, for Palestine. Yeah. Are they protesting Israel or protesting Palestine? Free Palestine. Yeah. Yeah. It's unfortunate. It's really sucky situation right now in Palestine and Israel. One group is like anti-Semitic and violent, and then the other group is like totally unsupportive of. Yeah, it's bad. Just overall, very bad. Sorry. Okay, so back to logistics. You know, the fun stuff. So homework 0, I'm not like gaslighting you. I don't keep moving it at the last second. It was due today, but then but we had switched. We were gonna work on it on Friday, and then we switched everything. I didn't really think about it until today as I'm looking at the due date. It's like, let's push it off one more time so that Wednesday's the day. We'll get it done. Today we'll load up Jupyter. It's running. We'll make some accounts, and then you'll have like your own little computing environment where we can work on Homework Zero and all the projects or any other kind of like Python and Jupyter development work. So that's the plan for today. Get Jupyter up and running, and then Homework Zero is kind of like reacquainting yourself with like how to read Python code and like do some calculations that way. And then on Friday, let me make sure my timing is all right. Yeah, Friday, we'll meet back up, build a proposal for Module 5. So Module 5 is like a 2-week, we'll spend 2 weeks. So it's not like a full thesis research project. It's a short, kind of like, can you come up with an application for dynamics? Do a little bit of research about like why you think that's important, either for you, for the larger like engineering community. But that's what Friday will be. And Wednesday we just have some free time. Take the day off. You could work on if you like. We have this hour blocked off. You could take that to finish up this Homework Zero, or take a break. But no class on Wednesday. Sound good? I'm pausing for questions and clarifications.
So no class this Wednesday?
No class Wednesday. There's a wedding. Yeah. I'm going to a wedding. You can do whatever you want, but I'll be at a wedding. Saturday. Smashing glasses. All right, cool. So we can try loading up this interacting with Python, like Module 0 work. And getting there. So if you're in Husky CT, like that's our main kind of jumping off point in general. You can, so let me get into student preview. So we have the same thing. We'll navigate the same way. So you can just jump straight into the syllabus, and the syllabus brings you to our website, like our main like open resource. And then this first link here brings you to like the Dynamics Jupyter Hub server. So it's a tool set that has this whole website as Jupyter notebooks. So let's click that. And then what will happen for you is, I'll zoom out one more. Up here, it'll say log in, like rather than logged in. So the first step is that we need to create a NanoHub account. And once you have a NanoHub account, you'll have it forever. You can always log back in. There's tons of other awesome computational resources on NanoHub. We're going to use like just the Jupyter notebooks as part of that. So what should happen when you click, so I'm going to open it as an incognito window. If I try to launch the tool, it's going to tell me, hey, sign in. And for the sign in, don't use Yukon here. Just either make a sign in with Google or create a sign in account below. So skip over that one. So either create an account or sign in with Google, one of those two. And if you create the account, you can use any email you want, even your Yukon email. Create a password, a username, all of that. So today, super fun logistical login information. And I think we have 2 students. You guys are in CompMech already, right? So you've already done this. In the back, Louis and I forget, sorry. You guys already signed in. You have it in account. Are you able to make an account? Done? Okay. Done. Did anyone already do this? Oh, you did? Wow. All right. Are you trying to go like right into the homework zero? Okay. Yeah, that'll work.
Yeah, because I keep getting now opening up, right?
Yep. Yeah, so from there, like if you click that rocket, and then Jupyter Hub, then it'll ask you to like log in or sign. Yeah, log in or sign. So you can use Google or you can create an account. Yeah. Yep. Yeah. Try clicking that. Slowly thinking about it. Nice. Created. Are you able to find like the? Yeah. So now you're like in your dashboard. You have to click on that like either a link from the syllabus or this rocket icon.
Should I make it from?
Sorry.
Should I do it?
Yeah. Then you and then click on that like getting started. And that opens up like a Jupyter notebook for you.
Before we do it?
Yep. Yeah, so there's like stuff to read, and then at the bottom there are like questions.
And we put a code like here?
Yep.
Okay. Alright.
I'm not trying to leave anybody behind. I can always back up for whatever we're doing, and it's all recorded, right? So we got. So as you, once you like log in, I think it plops you into your dashboard. So you have something that looks like this. Like it won't say Ryan Cooper because you're not Ryan Cooper. Unless you said my name is Ryan Cooper, then it'll trust that that's who you are. But something like this, it's like now you're in NanoHub, you're logged in, that's your dashboard. You won't have any tools or sessions or anything, but you're logged in, so we know we're logged in. Now, I just wanted to show what, so you can always click on this link on the top of our syllabus. So you can always go here to get back into Jupyter, and it'll always save, your work is always gonna be there. But you can also, if you're in any notebook and you wanna see the Jupyter, if you wanna like look at the Jupyter version of that reading or that web page, you can always click like the rocket button and click Jupyter Hub, and it brings you back to that launch tool for Dynamics. So we can always get there, kind of 2 steps usually. So launching the tool, like thinking, but once it kind of copies stuff in, and you haven't logged into like 3 other sessions. So let's close some of these out. I'll open this one. It brings you into like this first page called README. You can read me if you would like, but also every module has like all the links to all the Jupyter notebooks here. So this is our main like jumping off page. So getting started is our first homework problem, homework 0. Then it keeps giving this validation failed. Just ignore it. It's fine. Happens. I read that if you delete all the cells and then you paste them back, then the error goes away. I'm like, I'm not doing. We don't have to do that. It's fine. So navigating Jupyter. So if you've used Jupyter before, great. If not, that's okay. But it's a way of mixing some code, your outputs, and like your thought process of like why you're doing things all into one document this way. So right now there's like stuff that I wrote about like what do I think is important about Python and these kind of things. So holding shift and hitting enter will like execute the code and move on to the next cell. Execute, move on, move on. Your first program is always printing hello world. I don't make the rules, I just follow them. That's just what you have to do when you learn a new program, is learn how to print hello world. But now we're pretty advanced. We can print something else. We can print I'm Batman. And then it changes that output. So now instead of hello, it's Batman. Cool. Python, it is a calculator. Like if you're just doing like, if you're giving it numbers and like adding, subtracting, some of this is review because a lot of people use Python in CSE 1010. So it was used, registered, forgotten. Oh, but it keeps popping up? Oh, why? I don't like that. All right, so I am going to X and then V. But we can change this to one of the interesting things about, I mean, interesting depending on who you are, interesting to me, maybe not interesting to everybody else, but like if you're using all integers, like 2 and 2, integer, or 2 and 3, then it prints out an integer, like it's trying to do integer math. But if I change one of these to like 2.0, one of them is a floating point number, the other one's an integer. The only way to get both of them to kind of do math and maintain the same accuracy is convert them both to floating point. So in the next one where it's 2 floating points added together, the output is a decimal floating point number. Versus up here, you can change it 2 and 4. But just doing some math. All right, so now let's think about this. 9 to the 1/2. What is 9 to the 1/2? If I take 9 to the power 1/2. 3. What is this giving me? Why is it not 3? Yeah. Yeah, so it's saying 9 to the 1. Take that output, then divide it by 1/2. So order of operations it becomes very important. Like how are you putting like parentheses around stuff? So 9 to the 1/2, that's 3. 9 to the 1 divided by 2 is 9 divided by 2. And let's look at, all right. So if we're calculating like volume of a sphere, so these problems are like exercise problems, just like try it out. If they feel really easy, like you're welcome to skip over them straight into the problems at the bottom. But if it's if you feel like some of it's new, some of it's old, then start here because this is a nice place to start. So if I know diameter of a sphere, then what is total volume? How do I calculate that? What do you think? Try it out. What's the number that you get for volume of a sphere? 4/3 pi r cubed. How much is it? Diameter 6.65. Yeah. With Python, like type it in. We'll see what number we get. Oh yeah, if you actually like highlight it. Well, right there. So this is called a markdown cell right now. But if you want to turn it to code, you hit the button Y, and now it'll print out that output. Yeah. All right. So here's what I've seen, at least in our the one interaction that we had. 4/3 times 6.665 to the third. And yep. So I saw this so far. Whenever, if you don't have like a little thing that says in on the side, then you're creating what's called a markdown cell. So markdown is great if you want to talk about like, I am calculating the volume of a sphere. So maybe I would say, I am calculating volume of sphere, and maybe put this thing in like asterisks, like or dollar signs if I want to turn it into like LaTeX, or I could put these like little ticks in here, like back ticks, like that. And then now if I have an input here, now I can actually run like a Python code. So if it says in, then it's going to run Python and show me what the output is. So I'll try that again. 4/3 times pi times 6.65 cubed. What's the problem here? Why isn't it giving me an output? Because pi is not defined. So it's not like, it's called your namespace, like what variables all are available to you. Right now, pi is not one of them. If I want to use like, one of the most powerful parts of Python is that you can import whatever you want. Like there's tons and tons of libraries and functions and variables and all sorts of like great stuff that we can import. So what I could do is say from numpy, if I could spell, import pi. And that's going to go into the library called numpy and get the variable pi for me. Or I could define pi myself, like I could type out the numbers 3.14156, I think 156. And then now I start getting a result, right? Because I went into numpy, numerical Python, grabbed the value of pi, and now I can use it in my calculation. Is it right? Is this the right volume? No?
I think it's the
Diameter
diameter is 6.65.
is 6.65. So here, like if you want to see what the actual result is, you can like slide your highlighter over it. So we're off by a factor of 10, roughly 10. 8, or wait, yeah, about 8 actually. It should be a factor of 8 off, right? because we use diameter as a radius. Oh, so then all we need to do is just divide it by 2, right? Like that. Done. Should give us the right result.
6.65 over 8 now. So that 6.65 by 2.
Yeah. So we could do it like this, like put parentheses around it, and now we're good. So it's radius cubed, not diameter divide by 8. Or we could say diameter cubed divide by 2 cubed, but somehow get that order of operations. And now we're matching up with that 153. 97. We get 9797 because we're using a couple extra sig figs on pi. All right. What do we think for shipping? Wait, what do we need? We need, what is total cost for 60 copies of a book? It's $24.95, but you get 40% discount. Shipping is $3 and then 75 cents per copy. How do I turn that into just like calculator? Calculator, give me this, Python, give me this result. Nice. Are you trying to get like into? Oh, you're done. Okay. Cool. Okay. Yeah. So you can run everything in here, and then when you click the file print preview, you'll make like a static version of interactive, and you can print that. Yeah, you can just like add everything in there. Oh, nice. Okay, so you're in now. Now on that tab, click that rocket button. Click launch. Think about it. Copy the resources. Cool. Yeah, that's the main thing that we're evaluating. Do you like Jupyter Lite better? I didn't download that. Like right now we have this Nano Jupyter running. So if you have a Nano account, you can log in and save on. This is like online Jupyter board one. It's going to delete everything every time you log back in. Yeah, you can like. Okay. Oh, but you're logged in. Okay, cool. Yeah, now easy-ish way interacting tab. Rocket. And then it will, now you can say like launch that tool. Think about it and then persistent copy of all that work. That's okay. So when you hit, if you hold Alt and Enter, then it runs something and gives you a new one. And then the other options, clicking on insert, you can also like insert a cell above, insert below. So question came up about like if I only have one cell, like how do I get more stuff? You can always say like insert, click on that insert and say like insert above, insert below, like get more stuff. By default, it's going to be Python stuff. Like this is places for you to code. So if I insert below, then I have another place to start calculating. My goal is getting to that 945.45. So I saw a few people get that. What did you type in to get there? Let me do it up here. So how did we get to 24.95? What do we need? Times 60? Just multiply by 60. 60 copies. Yeah. And then we get like 60% discount, right? Cool. Cool. And then was that we had like 1 times 3 plus 59 times that 65. 939.55. Oh, whoops. Yeah, if I could actually write what you told me to write, then we get the right number. Nice. And that is what we were trying to get. 945.45, something like that. If you're like me and you like significant figures, you've been dealing with engineering stuff and you love units and significant figures, like how do I get this in the form that I want it to be, then maybe you like print statements. So total, oh, let's put it in quotes. Total cost is dot format. I'm gonna put a $sign. So now I'm starting to get, I can like document what my outputs are with print statements. So I can print out the variable and I can print out what that variable actually is, what units it is and all that kind of stuff. And with those squiggly brackets, I can start saying like, well, I don't need those 10 sig figs. I only need the first 2. So let me say like 1.2f. And now I get 945.45. 945 with like 10 nines after it, or 944 with 10 nines after it is 945. But again, if you like formatting outputs like me, and some types and all that. So I'm going to skip down to and skipping over a lot of the readings. Like definitely take a look at it, and maybe you've looked at it already. But coming down to the problems is the main like homework assignment. So you can do whatever you want above the problems. You can delete stuff, you can add notes, you can try calculations. And then when you get to the problems, this is where we're asking for specific outputs. So we have a box, we know its dimensions, how big is it, what's the volume? And then if we know dimensions, we know weight, we can figure out density, all these kind of things that roughly know how to do. Yeah. If you want to get more than one, oh yeah. All right, so let's try that. 12.5 times 11 times 14 I'm going to call it rho for density, is 31 over V. So now I'm getting a little fancy where I have like variables assigned to my calculations. So I'm saying V is something. So now that variable V is the volume and rho is the density. But if I just run this cell, nothing happens. At least like nothing, I can't see anything happen. What happened? Yeah, what's going on? What happened here?
You have to print the variables.
Yeah, we can print them. So if we're, so one thing is we could use one cell, like the cell, the last thing you put in the cell, like the last calculation will always get printed. So if I ask for V and I ask for rho, then those will show me like, okay, V just by itself will give me volume, rho will give me density, like that. So I could make a new cell for each of those, or I can come back up and say, kind of format my results, right? Print 1A volume is dot format V, and then print 1B density is dot format rho. And now I've got those two questions. I'm doing the calculations, putting them into variables, and then printing those variables, kind of like a two-step process. What are the units in all of this? Zoom out a little bit. $19.25. What is that? Meters cubed, centimeters cubed, cubits cubed, ounces. Yeah. Inches cubed. Again, I like units. I like sig figs. So for me, I would put in the fact that like, hey, this is inches cubed, so that when I go back and reread my code the next time, I'm like, oh yeah, everything should be in inches. If I want it in feet cubed, like that's fine, but then this has got to be over 12. That's got to be over 12, over 12. And then I could say feet cubed. So like 1.11 feet cubed. But I'll undo all of that. Get it back to inches. So now I've got inches cubed. What about density? What is that one? How dense is this thing? Density is weird because in English units we could have ounce per ounce. How many ounces is it per ounce? Because a fluid ounce is a volume, but then an ounce is also the unit of mass. Well, weight. US system is a little weird because it's force-based, not mass-based. The base unit is pounds in force, not like mass. So what is my density now? If I want to report the units. Yeah.
Just do inches cubed per pound.
Inches cubed per pound. Up there. Like that. Seem right? Oh, let's put a space there. So if I have 1 pound, it would be 0.016 inches cubed. Is that right? Yeah. Flip it around. Yeah. Do the in. And again, I like sig figs. 1.2 F, or maybe 1.3. Pounds per inch cubed. So if I have 1 inch cubed, then it's 0.02 pounds, right? I don't know how many ounces that is. Cool. I want to, so I can just keep running through and trying stuff, but I want to see like where people are at and see what are some focused Q&A that we can run. Or if you have questions right now. Yeah. Like right here. Oh, too far. On the left side of the decimal, that's telling like how many spaces I want on the left side. So if I said 10, like it would give it extra space. See how it like bumped it over? Like if I wanted it to be uniform spacing as I'm printing it out, maybe I would want like, yeah. So the left side is like how much space you want the left of the decimal to take up. So 1 is fine. It'll just use as much as it needs. And then the right hand side is saying how many significant figures do you want to use. So if I ask for 52, then it's going to try to print out as many significant figures as it can. At some point they become nonsensical because once you hit like 10 to the negative 15, a computer can't really, it reports it, like it does store it as an exact number, but it doesn't actually know if you only have only so many bits that you can really store it with. But that's a discussion for a whole nother class. But that's the left and right side of that decimal. It's like number of spaces and then how many significant figures you want. All right, yeah, I was getting that error too. So if you're getting that like validation fail thing, what I read the hack online is press escape on your keyboard so that now it's blue. See how my thing is like blue? Just hold the down arrow until you get to the bottom of the notebook. Hold the shift button, hold the up arrow until you get back to the top. So now the entire notebook is highlighted with blue things, not individual cells, but actual blue. Then you press X and V. And then it pastes everything back in, and then the validation stops coming up. It's kind of a weird hack. I don't know why that is the process, but it does work because I did just do it. Yeah. All right. So hold the.
You can also just do Control A to slap everything.
Control A. Yeah, Control A works. Thanks. Control A. Make sure it's a blue. Like this thing is blue.
Yeah.
And then Control A. And now hit X. X cuts everything, so it's still in your clipboard, and then V pastes everything. So not Control C, Control V, but C and V, or X and V. And then that error message stops popping up. I don't know why it's there to begin with, but it does go away after we do that. It does keep working. Like it has no problem with that validation error, but it just keeps popping up. So it does tend to drive one insane. Yeah. Oh, really? Did you click save or like Control S or something?
I just played it. I mean, I already.
Yeah, yeah. If you, yeah, click on File and then show it like preview. Yeah, and then hit Control P. Yeah, that's right.
Yeah, Nick was showing.
You want any one?
You can submit everything.
So that is for that. Discussion. We're gonna do the second one.
Do you want to do second? If you want, yeah, we can do whatever you want. Like in here. So this one is looking at like the second problem, looking at Boolean. Like you can compare whatever you want as long as it's the same. Python's big on objects. Like as long as the variable is the same object, you can do comparisons. So I can ask for string 1 less than string 2. What do you think? Is capital Python more than or less than lowercase Python?
How do you get that new line?
Oh, the new one? So you can click like insert and then cell below. And that'll make like a new cell so that you can start running stuff. So what do we think? More than, is this true or false? I mean, it's the same word, right? Shouldn't they be equal to each other? Maybe we should try that one first, right? That Python equals Python. But they're not the same because it's like capital P and lowercase p are two different things saved in your computer. So then let's try string 1 less than string 2. True, false? True. So capital P is less than lowercase p? Kind of weird. But if that one's true, then this one must be false, right? They can't both be true. Alright, so I'll show like so it's a file and then a preview, not just like static version. Yeah, so some people are kind of working ahead, so I'll show like, alright, I'm done with this. I just want to submit it. We can click File and Print Preview, and that's going to create like a static version of this like website that we've been working on. and it takes a second. But I have this whole thing, and if I come down, I can see like all the work that I've been doing, kind of scrolling down real fast. But this is like the latest thing that I just did, comparing these strings. Up here, I had my density, my volume calculated. Like, all right, good to go. So Control P or like file print somehow. Yeah, Control P, print. And from the print, there's usually some option, like for mine, it's a destination is a PDF. On Mac, I think there's an option to say save as PDF. Windows, I think, is also a destination. But I just want to save that as a PDF. 01 interactions. I don't need it in my receipts, so I'll put it in my downloads. I don't know, call it Cooper, just to keep track of it, and overwrite that one. And now I have like a PDF that I can throw into Husky CT and call it a day. Yeah.
Wait, you want to do the whole thing, the whole module?
Yeah, the whole thing is fine. You don't have to like just break out just the problems. Because in the projects, we'll have the same kind of Jupyter notebooks. Like the beginning is sort of stuff that you edit, and then the end is like stuff that you're analyzing. We at time? Yeah, people are ready. Oh yeah, we're overtime. Sorry about that. Thanks for the extra time. I appreciate it. Thanks for joining.